Hello, and welcome to this presentation, Getting Started with the CMA180 Basic Receiver Testing. In this presentation, we'll provide a short explanation of how to perform basic receiver testing of two-way radios using a Rohde Schwarz CMA180 radio test set. This presentation only covers how to test the receive portion of a two-way radio. Please see the separate presentation, Getting Started with the CMA180 Basic Transmitter Testing, if you'd like a similar explanation on how to test the transmit portion of a radio. There are two steps in testing two-way radio receivers with the CMA180. Basic functionality can be tested by configuring the CMA to generate an audio-modulated RF signal, which is routed to the device or radio under test. The radio demodulates the RF and outputs the audio signal via a speaker or headset, and this audio signal is then checked by ear to verify proper reception. A somewhat more advanced test involves routing this audio signal back to the CMA180 for quality analysis of the received audio. This includes traditional audio measurements such as total harmonic distortion, signal-to-noise ratio, etc. In this presentation, we'll go through both of these types of tests, beginning with basic functionality testing. For our test setup, we'll connect the CMA180 to the radio under test by removing the antenna, and then connecting a cable between the CMA's RF COM connector and the radio's antenna connector. We'll then generate an audio-modulated signal from the CMA and listen for audio output from the radio. To run this test scenario, we start by going to the global toolbar and then selecting RX, that is, receive, under the Analog tab, since we're testing the receive portion of the radio. The RX test main screen can be divided into two areas. On the left are the generator controls, which are used to define and transmit the RF signal that will be received and demodulated by the radio under test. The right side of the screen contains the analysis functions. For the first step, that is, verifying basic functionality, we only need to configure the generator section, since we'll be using our ears to do the analysis. In the generator panel, we first configure the frequency, the mode or modulation type, and the deviation to match the radio under test. We also need to configure an appropriate output RF level, especially if squelch has been enabled on the radio. By default, this carrier will be modulated by a 1000 Hz tone. Clicking on the configuration icon allows you to select the output RF connector, as well as to enter any external attenuation in the signal path, for example, any cable or connector losses. To start and stop the generator output, use the Play Stop button at the top of the generator pane. Next, let's look at audio analysis. Our test setup for audio analysis is the same as for basic receiver testing, except that instead of testing the audio by ear, we route the audio output of the radio to the AF1 in connector on the CMA180. Most radios have some kind of jack or port which can be used for audio output, but it may be necessary to wire an appropriate cable to connect this output to the B and C connector on the CMA180. We'll assume that we're using the same generator configuration as before, in which case we simply need to enable both the generator and the analyzer. At this point, if we enable the CMA's built-in speaker, we should hear the demodulated audio from the radio under test, in this case our 1000 Hz tone. This is the main analyzer screen, which shows measurements made on the demodulated audio signal from the radio. The results are divided into tabs, with the Overview tab providing a summary of the most important measurements and views. The AF Results tab shows more detailed numerical results, and the AF Spectrum tab shows level as a function of frequency. Let's now take a brief look at each of these last two tabs in a bit more detail. The AF Results tab displays numerical values for several different audio quality measurements, such as total harmonic distortion, synad, and signal-to-noise ratio. Note that these measurements require the RF input signal to be modulated by a single frequency tone, which by default is a tone with a frequency of 1000 Hz. Different frequency tones can, however, be used, and the frequency of both the generated and analyzed tone can be automatically coupled together by going to the AF Settings tab under Analyzer Configuration. The AF Spectrum tab shows amplitude as a function of frequency, and this can be useful when examining the received audio signal for harmonics, distortion, noise, etc. The small configuration icon can be used to reduce the frequency span, and can also be used to select a different type of FFT window if needed. Let's end with a brief summary. The Rohde Schwarz CMA180 radio test set can be used to perform both transmit and receive testing on analog two-way radios. And in this presentation, we've walked through how to test the receiver portion of a radio. For this type of testing, the CMA180 generates or sources an RF signal with a user-defined frequency, power, modulation type, and deviation. This signal is modulated with an audio signal, usually a 1000 Hz tone. Basic receive functionality can then be tested by connecting the radio to the CMA's RF output and listening by ear for a tone from the radio speaker. More sophisticated testing involves routing the radio's audio output back to the CMA180, or more detailed audio analysis can be performed. This analysis includes traditional audio measurements, such as total harmonic distortion and synad, as well as spectral analysis of the audio signal. This concludes our presentation, getting started with the CMA180 basic receiver testing. If you'd like to learn more about radio test or radio testing with the CMA180, please see the links in the video description. Thanks for watching. Please subscribe to our YouTube channel and visit us at rohde-schwarz.com.